can be associated with stratovolcanoes, it more often is associated with the formation of lava domes. And, indeed, the dacite of Morro rock was associated with what was likely once a growing lava dome volcano. However, the dacite you see here is technically a hypobasal rock, also known as a subvolcanic rock, meaning it is technically an intrusive igneous rock that cooled at shallow depths of less than 2 kilometers or 1.2 miles. In the case of Morro rock formation, the dacite lava present represents the less eroded remnants of the rising magma which once filled much of its magma conduit, rather than the actual peak of the original volcano. It just so happens that the softer surrounding ground and rock along with the original lava flow which was more susceptible to erosion eroded away millions of years ago, causing the harder intrusive igneous rock which was more resistant to erosion to become exposed on the surface, hence its modern appearance. In other words, Morro rock represents what is known as a volcanic plug. Hypothetically speaking, if I was to cut away the top 3,000 feet of this lava dome emplaced in 1350 near Mono Lake and let some erosion occur, it might eventually create a similar looking feature. Looking around, you might note that there are other nearly identical features nearby. 2 miles to the east-southeast, you have Black Hill that is also made of dacite, the Nine Sisters representing yet another volcanic plug of a similar age. Yet, this chain of similar-looking features continues onwards, encompassing at least 13 total volcanic plugs, with some sources claiming the actual figure as 23 that extend along the lineament for 17 miles. Altogether, these volcanic plugs are known as the Nine Sisters, even though there are more than 9, just don't ask why. Each of these plugs within the Nine Sisters formed between 26 and 20 million years, associated with viscous magma intrusions that fed a likely monogenetic chain of volcanic vents along an ancient fault line. However, this raises another question. Why would a cluster of volcanoes just suddenly form here in relative isolation around 25 million years ago? While we still aren't 100% sure, here is one possibility that I deem to be plausible. Mid-ocean ridge 30 million years ago, the large Farallon tectonic plate offshore of California was subducting underneath the North American plate. However, at the same time, as this plate moved eastwards, a section of a spreading mid-ocean ridge began to be subducted. Since this mid-ocean ridge contained crust which was very thin, it allowed for molten rock in the mantle to rise through it and then intrude into the overlying tectonic plate. While some of this magma erupted onto the surface, other portions did not and remained at shallow depths, cooling to form a series of dacite to rhyolite monoliths. These volcanic plugs, which were once oriented south to north, were later rotated due to the motion of the San Andreas Fault and nearby terrains counterclockwise by 45 degrees to form their modern appearance. Are there any other local geologic formations that you want me to discuss? Be sure to let me know in the comment section below. As a final note, I would like to thank my new YouTube channel member Joshua Friedman for